Thank you. So I just need you to once have an example of when things are truncated or cut, right? I need you to be able to do those and just think them through. And I have a feeling that by now you've seen so many examples that you probably will already know how to approach this. But we'll do surface area and volume of something like this. This has come up, you know, paper cups, right? Sometimes paper cups they look like this. And so there was a question on the exam, like, hey, figure out the surface area of this paper cup. And they kind of they hint towards, these are really two cones. I don't know if you see it. There's a large cone and a small cone. That's what I want you to think of. Think of the thing that's being removed as something that you obviously have to remove as part of your math, right? Sometimes you have to think carefully, is the top closed or is it open? If it's a cup, it's open, right? Then you would not want to include the circle. So you have to be very careful what the scenario is trying to tell you there. So let's do total surface area. I'm going to do that here because I feel like surface area always run out of space. Okay, so we're going to do total surface area. We're going to go surface area of the large cone minus surface area of the small cone. Actually, hold on. This is it depends on the situation. If we want this base to remain, okay, we would only subtract what? Just the LSA. All right? So I'm going to go minus the LSA of the small. So think of this. This is the large cone. It's inverted, of course. You remove the LSA. If you want the small circle, if you want that to remain, you would go small circle. I'm just going to go circle like this. Plus small circle. And what about the top? Is that already included in any of my previous formulas here? The surface area of the large cone includes this already. So think about it that way. You're including everything. Minus LSA of the small, it's just taking away the side. I would still have to add this little small circle here if I wanted this to be a cup that is closed, or this is closed on both sides in this particular case. If the top was open, I would, in this part right here, only mention LSA. Right? You're not going to start with this being closed, but I assume this is closed. So I go surface area of the entire large cone minus LSA plus the small circle. Okay. I have a feeling this is going to throw you off. So I'm just going to go small circle. All right, so now we know that that's what I mean. So let's go and do this. So this would be pi r squared. I'm going to go capital R, right, plus pi rs. And here's another, it's a slant, right? It's this one here. This is slant. Capital S slant. It's like the whole thing. So I'm going to put square brackets around that. That's like my cone minus LSA of the small. So that would be pi lowercase r lowercase s. Okay? Where is the lowercase slant? Where is it on here on the diagram? It would be from here to here, right? This is lowercase s. And I need to do a little bit of calculating here, correct? I need to go 7.85 minus 4.32 to give me the 3.53. So the slant height of the small cone, right, is right here. That's the one I'm going to use for this part. plus the small circle, that's just pi r squared like that. That's really what it comes down to. And now it's just a matter of you plugging it in. Okay, so pi, radius of the capital R radius, let's go ahead and do that on the diagram. Capital R would be 1.625 inches. Lowercase r, half of 1, 0.5 inches. And let's just plug in. R squared would be 1.625 squared plus pi r s, that's the slant for the large one, right? So that would basically be the first square bracket minus pi r lowercase s plus pi lowercase r squared. And I just want to emphasize again, I think it's very important to know what the formulas are doing. If this was a cup, you would not want to include this part right here, because the big circle, you would want that open. So that would not be a surface to be included. Okay. But this doesn't have a word problem around it, so we're just going to go for it here. So I'm just going to go off my key here. You get 48.37 something out of all of this. Okay, minus 5.54 something out of all of this. And then plus 0.78 something out of this, which is obviously small, but we would still consider that significant. And here it is, 43.61 squared inches. That's the total surface area of the truncated cone. And let's do the volume. I'm able to fit that underneath all of this, so I'm going to do that. I prefer, though, it'd be nice to have it on right beside the cone. I'm going to give it a shot. Let's try it. Total volume. That would simply be volume of large minus volume of small. That's it. So that would be pi r squared h divided by 3 minus pi r squared h, all lowercase, divided by 3. And you know that this is going to be extra work, right? Finding the different heights. So we'll go ahead and do that. Let's do that off to the side on the left here, if you can. Let's just do that off to the side here. So I'm going to take this, and I'm going to go height capital H like that. Okay, and so if I think of the whole thing as 7.85. And what is this part right here going to be? This one. That is going to be the radius of the cone, right? Because it goes right to the center here. That's what this is. So 1.625. So to find height, it's going to be square root of 7.85 squared minus 1.625 squared. That's root of 58.98 something So capital H is 7.67 inches. Important. I'm going to underline that. Should have started higher up, eh? Lowercase h. This is 0.5. That's going right into here, and you want the height of it. And we do know the slant of the smaller cone is 3.53. So h is right here. Lowercase h is simply hypotenuse squared minus the leg squared. That is root of 12.21 something. H is 7.67. No, 3.49 as I was saying. Inches. Also important. I will give that a highlight in a bit. I'll give that a color, give this a color, and then slap it into this here. Okay, we're finished stretch here. Obviously, you hope that, right, like you do want to have this in your notes and know how to do it. But the best would be to think through it and deduct it yourself. So we go like this. Minus pi 0.5 squared. And that's the lowercase height. All of that divided by 3. Total volume. If you do the first part, you get 21.23 something. And you with your fancy calculators these days, it does make this a lot easier to not have to worry about rounding along the way. There's your total volume. Let's give it some color here so you see where everything came from. Like the height here goes there. This lowercase height went there. So volume in a sense is usually pretty straightforward, except for if you have to do the extra work with finding the height. And that would be the case for a cone. Or if you have a triangle show up, then you have to be alert and watch out for that. If you don't mind, I'm also going to give the slant here. Right, that it's kind of mixed up there. That's this one right here. And that's the one we use here. And I'm going to go pink. This one right here went over here. Fun stuff, eh? Yeah, I know. So very busy, very busy. Okay. All right. Enough of me talking. We've got what? Half an hour? Good stuff. I'm just going to point you to, if you want to practice this one in particular, page 28. If you want to have another go at truncated cones, try page 28. You will see it there. I'm not too proud of that diagram. I just use Microsoft Word and it just shifts but if you're careful, you'll still figure it out. It's a flower pot. Last time I checked, the flower pots were open at the top, right? Yeah, those are the ones you want for plants. Anyways, so watch out for that. Um, there was one more project I wanted you to work on. Yeah, now it's a good time. Did I assign you 37 already? The gravel, I'm pretty sure I did. Did you finish it? Did you check the key? I hope you did. Okay. There's going to be one major project on the test. One like, by major I mean like this, like lots of stuff, excavating, or filling with concrete, or area like adding and subtracting, and or subtracting. So watch out for that. I'm gonna have. I'm not gonna tell you that there's gonna be a truncated cone or not, but like the ACs they've been writing, which I'm gonna hand back. Probably to I want to start handing them back today. Those ACs, keep them, look at them, learn from them, make sure you understand how to do it. Maybe do it on loose leaf one more time. Okay. There are a bunch of pages, like page 21 and on, lots of composite shapes with holes in them and whatnot. Know how to do backwards. Like if I give you the volume, how do you get the radius of a sphere? If I give you the volume of a cone, how do you get the radius there? Those kinds of things. And please do not forget, let's do a quick mental math here. On the back of this booklet. I don't know why I do a heart, but hey, let me do my thing, okay? If I told you the bottom of a prism, the base of the prism has an area of this. A prism is something that has a base and it just keeps extending up. Okay. I don't know if this is going to work or not, but I think we can make it work. Hey, and if I told you there's like this prism and it has a height of 10, what's the volume? What would you say the volume is? It's actually very straightforward. Area of heart times 10. Okay. The volume is 500 squared inches times 10 inches. That would be 5,000 cubic inches, right? Inches squared times inches is inches cubed. So don't forget, I'm thinking of one that will confront you with this knowledge. So be careful, watch out for it. Okay? It's just it's very important that you understand that. So I can give you any shape here at the bottom of the base. If I give you the area of it and the height, you should be able to figure out the volume of that shape. Okay? It could be a pentagon, hexagon, it could be a square, it could be anything. Okay? So keep that in mind. I want to give you some class time because I know you need it. If you're done 37, I want you to do 41 as well. Okay. So basically, if you want to give it a try, is page 28 is the truncated cone, and then page 41. Plus anything else you need to do. Okay. I'm not going to give you another AC to take home today, so this is just it. Like, just work through this. You've done well. Most of you have done the work, and I appreciate that. So for now, just work. I will post the key, and then I'll walk around if you need help.